and then the implications of this for me as an individual, for us as a society. And a broad and balanced approach to computing education needs to encompass, I would argue, those three domains. As Neil's already indicated, the computing curriculum is incredibly brief. In England, it fits on 2 sides of A4. You don't need to copy all of this down. What we have there is little more than the building regulations. It's the minimum entitlement. It is a statutorily prescribed thing. Local authority maintains schools have to teach the national curriculum, but the way they do that and what else they do as well and what resources, what schemes of work they choose to support that work is entirely up to them. So we have the building regulations, but each school is responsible for its own plan of doing that. The architect's plans have to comply with the building regs, but the architect's plans are down to each school in terms of their local context, their vision for learning, for teaching, for education, the resources that they have at their disposal. The textbook can bridge the gap from one to the other. So our Minister of State for School Improvement sees the textbook as providing the fleshing out of the content of the programme of study. The programme of study is very minimal, but a good textbook bridges the gap and shows what that means in practice and provides a structure that schools can use to deliver a rich education base which complies with the programme of study that goes far beyond the minimum requirements there. You have, if you will, for those of you with a background in software engineering, something akin to a waterfall development process. Government publishes a list of requirements and this is what should happen. There's then the process of designing schemes of work, of textbook schemes or resources or whatever, which implement something which meets those requirements. The job of then doing that in practice is down to teachers in classrooms who have had very little say in either of the first 2 steps on this model. There's of course the need to test whether that works, to verify whether that's being effective, and if it's not, then there'll be the maintenance pack, the upgrade at some point, I'm sure, which brings things back closer to the original requirements, or maybe the original requirements change. So our Minister of State can make statements like, counting as a success when teachers are able to laminate their lesson plans and use them from year to year. I share this, though, with my colleagues teaching in primary and secondary schools in England, and they laugh when I show this slide. The primary teachers laugh because they say, I have a different class every year, the children in front of me are different, how can I just teach the same lesson every year? Secondary colleagues laugh at this slide because the curriculum changes, or rather the exam specifications change so frequently that they need to move with that rather than the curriculum requirement. I would take issue with this because it's only my perfect lessons that I want to laminate. When I've taught a perfect lesson, then I should laminate the plans. But until then, I should be able to improve that continuously from one year to the next. So I'm not sure that the laminated lesson plans entirely solve the problem there. Alongside waterfall development, we have the other model of agile development. And I think for teachers in England, this is much, much closer to their vision for what education should be like. So yes, the things on the left of this slide matter, but actually the reasons they become teachers is much closer to the statements on the right-hand side about being responsive to change, about focusing on the individuals and the interactions with the children who are with them in the room, rather than necessarily following a comprehensively documented, rigorous process there. And there is that tension in English schools, and so textbooks have not been popular in English primary schools. I think going back to the 1960s with a very influential report for English education, the heart of the educational process lies the child. And teachers in English primary schools still, a good, how many this is like almost 50 years on from the Plowden report, see their job as about developing children's love of learning rather than necessarily passing on a particularly restricted or circumscribed body of knowledge. Nevertheless, there is a lot of interest in England about doing textbooks well, and so one of our leading education academics, Tim Oates, has looked at globally the best textbooks and makes a number of observations about what a really good textbook should be like. And from the slide there, underpinned by well-grounded learning theory and theory regarding the subject-specific content. Nobody in the room would disagree with that. English teachers would not disagree with that. It should be embedded in the best possible practice. Our Education Inspectorate, who are hugely influential in English education, also make recommendations about what a good curriculum looks like. Just picking out from that, the curriculum should be broad and balanced, with all three strands of computing covered well for all pupils in computing lessons and across the curriculum. The contexts in which computing are taught should be relevant to people's lives and reflect the increasing use of computing in the world of industry. Links should be forged with other agencies and the wider community to provide a wide range of enrichment activities to promote pupils' learning and engagement with the subject. Very, very similar to the vision which you've already heard of textbooks to support software education in Korea. And further points from our friends at our Education Inspectorate. Pupils are expected to use their computing knowledge, skills and understanding realistic and challenging situations. So that's not a requirement, but it's certainly an expectation of what outstanding computing education should be like. I want to move on to look at the resources which we at Computing at Schools have developed together as an organisation. Many of our members have produced their own teaching resources. What we've done together as an organisation is produce resources for teachers. We see the real issue in terms of teachers' own subject knowledge of computer science. And so one of the first things which we did was produce the guide to the new curriculum. The curriculum, as you see, fits on 2 pages of A4. We've produced slightly more extensive guidance notes to that about what the words mean and what that's going to look like in practice for both primary and secondary education. I think our model comes down to this, that outstanding education in computing rests on great pedagogy, great teaching. Also, a good set of technical skills, being able to make the machines work seems to matter, as well as computer science subject knowledge. We take the first two almost for granted, but the third one there, the computer science subject knowledge, is new for our teachers. We're expecting our teachers to teach something they themselves were never taught. So we have the Barefoot Computing programme, aimed particularly at primary schools, which addresses exactly that computer science subject knowledge through a sequenced set of subject-based workshops where teachers come together to learn about computer science, where there are teach-yourself resources online for them to print off and read, and activities that they can put that into practice with their own pupils in class. So we have this approach to computational thinking, which, yes, recognising those fundamental concepts such as logic, such as algorithms, such as course as abstraction, but also a cluster of approaches that computer scientists and software engineers engage in, like tinkering with things, like making things, like fixing things when they go wrong, which is an important part of our curriculum, like persevering when things don't go well, and of course, as already been indicated, collaborating, working together. We've also produced the CPD pack, the shrink-wrapped pack, for teachers wanting to run continuing professional development sessions for their colleagues, and that's badged as Quick Start Computing for primary and secondary. And this is all under a liberal Creative Commons license. Download that, feel free to translate this into Korean if you would like to. I want to move on now to Switched On Computing, which is my commercial scheme of work for the primary age, I should say, our award-winning primary scheme of work for computing. And for this, we started from this English phrase about not throwing out the baby with the bathwater. Does that translate into Korean? I wonder that there was nothing on the old ICT curriculum that we rejected. All of the old information technology is still there, but we added on some new. So we started with something that was working well and have now tried to make it work better. When we scoped out Switched On Computing, we took the curriculum and saw 6 strands running through it. Programming, computational thinking, networks and the internet, very important ideas, together with perhaps softer IT areas such as communicating and collaborating, creativity and productivity. These are not disjoint areas, but they are 6 areas of focus. So that divides nicely into the computer science bit and the information technology bit, embedding the digital literacy implications across all of that. We had a very successful product already, Switched On ICT, and we edited that, we revised that to make Switched On Computing. So the pink strands on there is where we had units in Switched On ICT, which we revised to reflect the new expectations, and the blue units are where it's new work written entirely, you'll have to forgive the expression, from scratch to start that. Down the bottom here, Year 6, a complete new unit of work focused on developing apps across the whole of the year. So planning the app, finding whether there would be a market for it, designing the user interface, then doing the coding, and then testing and marketing that. And this has proved very, very successful. For this, we've used, wherever possible, free resources, commercial scheme of work, as I say, so we're drawing on software which is available freely to use across schools. So of course we're using Scratch for programming, but we're also moving on to App Inventor or App Maker in those Year 6 units I touched about, and similar things for the information technology side of this. I'd say, or we would say, that we were allowing about an hour a week for each of 6 years for this scheme of work. And that's quite different from a 17-hour computer science curriculum in primary education. What does it look like? It's a teacher's guide, it's not a textbook. We're very much in the model of this is a plan for teachers to use, and they then teach their pupils to do this. They set meaningful, challenging activities for pupils rather than give them a book to follow there, which may or may not work in other contexts. So we introduce the topic, we put it in the context of the computing program study, we provide a little bit of information about what that means, we warn them about some of the safety issues which might be associated with using particular tools, and give them links to places they can go to read more. We then break each unit down into 6 steps, and then detail bullet point by bullet point. It's an algorithm for teaching this particular objective, I suppose, and then ideas for extension activity at school and home. We also bring in assessment there with fairly detailed criteria of what to look for in terms of what a child should be able to do. So a child following that unit of work should be able to break the scene down into smaller sections, write a program in Scratch to create an animation, but the most able in the class might also be able to think logically to detect and correct errors in their algorithm or their program, and perhaps publish their animations out to the Scratch community website. And they then link to digital badges, so a child provides evidence of being able to do all of the particular things for one badge, and then can have that badge to wear on their blazer or on their blog, depending. So here we have the sort of criteria for one of the programming badges at younger elementary and then older elementary level. On the back of that, our colleague Claire Lotrier has produced for the same publisher our Learn to Code sequence of books, which is much, much closer to a textbook-like approach. You follow these steps. Here is a plan for your program, and then you get to see this in action. There are copies of that outside if you'd like to have a look at it later, or at least to switch on computing. Moving on to Compute It, which is a scheme of work that, textbook scheme that Hodder have produced for lower secondary education. The approach there has been a somewhat different one, in that firstly it's a traditional textbook-like approach, and secondly they've focused particularly on the computer science elements of the curriculum. So they've taken the assumption that information and technology and digital literacy was being done well in secondary schools, but computer science, the new bit of the curriculum, was where the greatest need was for a textbook. And they divide the curriculum for computer science into those 6 strands and have very detailed progression planning through each of these 6 strands. I'll just give you a moment to note all of that information down. Okay. They then take the contents of computing, then forms the outline of a scheme of work there. So I'm sorry the text is so small and only in English on the slide there. But in Unit 1 in year 7, so our 11-year-olds in secondary school, what's under the hood of a computer? Thinking like a computer scientist, which is obviously bringing in computational thinking territory, and then drawing and manipulating shapes. Taking that as an example, this is what the textbook looks like. So here is the pupil-facing text. This is the sort of information which the young person, the 11-year-old, would be given. And there's a challenge activity there at the start. So yes, it's a textbook, but it's a project-based approach to teaching computing. Your challenge is to write a program that creates an artwork based on drawing and positioning shapes found in Celtic or Islamic art. And so it starts very simply with the turtle, the logo language to draw a square, and then moves beyond that relatively rapidly. Alongside that, of course, there's the teacher's guide. There's also very good online support materials, so there's this dynamic learning website where PDF versions and interactive activities are all available, together with the notes that the teacher needs in order to contextualise what the pupils are working on from the textbook there. Okay, I want to move on though to think about the broader ecosystem that sits around these textbook schemes. I should firstly say other textbooks are available. I've just picked a couple of examples there. We don't have any sort of government approval for textbooks there, although both of these are probably the dominant products in their respective marketplaces. So looking at the broader ecosystem, this isn't about education. This is the government digital service in the UK, the people who make our government's website, have as one of their design principles this fairly political statement: government should only do what only government can do, which is a very small government approach to things. That if the sector, the broader public sector, voluntary organisations, commercial organisations can do something, then government doesn't need to do that. And so letting the market decide what's a good textbook, letting the market and the voluntary organisations produce materials, our government has decided to step out of that, to create a very minimal statutory curriculum and then let the people decide how to implement that. And that perhaps is quite different to other approaches. A former Secretary of State for Education, the man probably responsible for having computing there as a national curriculum subject, Michael Gove, when he talked about the changes, mentioned this sort of wiki approach to a curriculum. That beyond the slimmed down national curriculum, he said we should consider how we could take a wiki collaborative approach to developing new curriculum materials, using tech platforms to their full advantage and creating something far more sophisticated than anything previously available. I'm not sure whether we've realised that vision, but it certainly informs some of what we've done. But any of you are involved in open source software, you have the classic essay from Eric Raymond about the cathedral and the bazaar. And Raymond contrasts the